Today we're going to look at more characteristics of graphs. First of all, we're going to look at relative maximums and relative minimums. This is where a graph will either change from increasing to decreasing and you have a little hill, or from decreasing to increasing and it looks like a little valley. Then we'll look at whether the function is even or odd. An even function, in addition to what it says here, is symmetric across the y-axis. An odd function, in addition to what it says here, has rotational symmetry around the origin. The way that you test for those two different kinds of symmetries is by replacing x with negative x, simplifying the function as much as you can to see what happens. If you get the original function back, it's even. If you get the opposite, you can factor a negative out of everything and you get the same thing back. Then it's an odd function. All right, so now we're going to learn how to get all of that information from a graph. First thing we're going to look for is intervals along which the graph is increasing. In order to determine that, think about tracing your pencil from left to right. So just like we read a book, we read a graph from left to right. If your pencil is going up, then the graph is increasing. If your pencil is going down, the graph is decreasing. For our graph, starting off to the left, our pencil is going up until we get to the top of that hill, which occurs at -5. So the first interval on which we're increasing is from -infinity, that's our x value, up to, but not including -5. Technically, it's no longer increasing at -5. That's our turning point. And at that point, our pencil starts going down until we get to -3. So we are decreasing from -5 to -3. We turn again and we start increasing up to just shy of 1. We'll call that 3/4. So from -3 to +3/4. Then we turn and start decreasing. And there's a short little part of this graph where it's constant. So I'm going to say we're decreasing to about 4 1/4. And like I said, we had that short little piece from about 4 1/4 to maybe 5 1/2. And then our graph continues to decrease to +infinity. Next, we're going to take a look for any relative maximums. Remember, this is the hill. It's where we change from increasing to decreasing. And these will be ordered pairs. So at -5, 4. And we had another one up here at about 3/4, 7 1/2. Then we'll look for relative minimums. This is where we have the valleys. There is not a relative minimum over here where it's constant because the graph continues to decrease after that. So it's not changing from decreasing back to increasing. That's when we would have a relative minimum. So we only have one relative minimum on this one, and it's at -3, 0. To test a function for symmetry, you replace x with -x. Everywhere there is an x on both sides, make sure you use those parentheses so we can get order of operations correct. What happens when you square a negative? It becomes positive, so we get our x squared back. And this is equal to the function we started with, so that shows that we have an even function. As a quick example of what this would look like on a graph, so you can see that symmetry. This is a parabola, and it would start down 5. What we just did, replacing each x with a -x, is showing that whatever happens off to the right of 0, 0 is the same exact y value that we would get off to the left. So for example, if we subbed in 1, we would get the exact same y value as if we subbed in -1. That's the definition of an even function. Checking this function for symmetry, if we replace x with -x, everywhere there's an x on both sides of the equal sign using those parentheses again. This time, when we cube a negative, it stays negative. This one appears like it might be odd because that x value is opposite. However, if we factor a negative out of the entire equation, we would get a -8. That x cubed minus 8 is not the same function that we started with, so this is neither odd nor even. However, to show you what an odd function looks like, it has symmetry around the origin. The parent function x cubed is an odd function, and it looks like this. What that testing for symmetry does is it looks at whatever happens off to the right, the exact opposite happens off to the left. So whatever value we put in for 2, for example, we would get the opposite value out when we put in -2. You have 2 U-Try questions today.